We're continuing our discussion of the production of an electron-positron pair problem. In part A, remember for this setup here, we have a photon hitting a stationary particle with mass capital M, producing an electron-positron pair, each making an angle phi with respect to the x-axis, and the particle continues along the path of along the direction of the incident photon with velocity v sub capital M. So in part A, we have written the energy conservation. Part B, we have written the momentum conservation. We combined the two, and then we looked at the limit for which V capital M is much less than C, and obtained an expression for V capital M, as you can see here. Now, let's move on to part E of the problem. Are there choices of V and phi for which V capital M is zero? That is to say, is it possible that this particle stays stationary after this scattering event when the electron-positron pair is produced? So if I look at this expression here and set V capital M equal to 0, V capital M is equal to 0, this will imply C is equal to V cosine phi. Now, cosine phi is a number that is less or equal to 1, which implies that if it is equal to 1, V is equal to C, and if it is less or equal to 1, V is greater than C. So since V has to be less than c, less than the speed of light, this is not possible. So the stationary particle cannot stay stationary in this scattering process. Let's move on to part F. Suppose the target particle is a proton. So that's the particle with mass capital M. If the electron and positron remain stationary so that V is equal to 0, then with what speed does the proton move in kilometers per second? Okay, so if the electron and the positron are stationary, that is to say V is equal to 0, that means gamma is equal to 1. So if gamma is equal to 1 and V is equal to 0, you can see here gamma is equal to 1, V is equal to 0, gives me for V capital M 2mc divided by capital M. So let's substitute the numbers here. The mass of the electron, rest mass, is 9.11 10 to minus 31 kilograms. Electron and the positron the same. The capital M, mass of a proton, is 1.67 times 10 to minus 27 kilograms. That's the mass of the proton. So if I substitute these numbers for the electron and positron to be stationary in this collision process, I will have 2 times 9.11 10 to minus 31 times 3 times 10 to 8 meters per second divided by the mass of the proton, 1.67 times 10 to minus 27 kilograms. I calculate the speed of the proton to be 3.27 times 10 to 6 meters per second. So this is possible. It's less than much less than the speed of light. So the electron and the positron can stay stationary if the proton gains this speed. Let's move on to part G. If the electron and positron each have total energy 5 mega electron volts and move with phi is equal to 60 degrees, Then what is the speed of the proton? Hint, first solve for gamma and V. Okay. The energy, the total energy of the electron is its rest energy, mc square, plus the kinetic energy, gamma minus 1 mc square, which is gamma mc square, and this is equal to 5 mega electron volts. Okay, so I can solve for gamma here. Gamma is equal to 5 times 10 to 6 electron volts multiplied by the electron charge to convert to joules, 1.6 10 to minus 19 coulombs, divided by the rest mass of the electron, 9.11 10 to minus 31 kilograms times c square, 9 times 10 to 16. So this gives us a gamma of 9.76. Now at the same time, gamma square is equal to 1 over 1 minus v square over c square. So this implies 1 minus v square over c square is gamma to the power minus 2. Okay, so if you multiply this with c square minus v square over c square is gamma to minus 2. So if I look at 1 minus gamma to minus 2, that's v square over c square, multiplied by c, and take the square root, I obtain c square root of 1 minus gamma square is equal to v. So if I substitute the numbers here, v is equal to c times square root 1 minus 9.76 square root. So that is equal to 0.994 C. All right. So I have calculated V, or V over C rather, that's 0.994. So I can substitute that to this expression to calculate V sub m, capital M. V sub capital M is equal to 2m gamma over capital M. So 2 times 9.11 10 to minus 31 kilograms times gamma 9.76 divided by capital M for the proton 1.67 10 to minus 27 kilograms. And then I have C times 1 minus V over C cosine phi. So that is 3 times 10 to 8, 1 minus V over C, 0.994. And for cosine 60, I have 1 over 2 times 1 over 2. So cosine 60 is sine 30, which is 1 over 2. This gives me the speed of the proton to be 1606 kilometers per second, which is much less than c, so therefore it is non-relativistic. Therefore the expression I used was correct. Okay, so part H of the problem. What is the energy of the incident photon in this case? From the energy conservation, I have the incident energy hc over lambda. This is equal to twice the energy of the electron plus the kinetic energy of the proton 1 over 2 m v capital M squared in the non-relativistic limit. So this tells me that the energy of the photon will be 2 times 5 10 to 6 eV plus 1 over 2 1.67 10 to minus 27 kilograms 1.606 times 10 to 6 meters per second square, and if I divide this by the electron charge I will get it in electron volts, so 1.6 times 10 to minus 19 coulombs. So here I obtain 10 times 10 to 6 plus 1.346 times 10 to 4, which means the energy of the photon is roughly equal to the energy of the electron-positron pair, that is 10 mega electron volts. Okay, so in this part of the problem, we checked if it's possible to have a stationary particle during this scattering event. Setting V capital M equals to 0, that means C is equal to V cosine phi. This would imply that the speed of the electron and positron need to exceed or be equal to the speed of light, which is not possible. In part F, we asked for stationary electron and positron after the scattering process. And for that to happen, what should be the speed of the proton? And we have substituted here V is equal to 0, gamma is equal to 1, and solved for V capital M. In part G, we had 5 mega eV energy for the electron and positron and 60 degrees scattering angle. Then what is the speed of the proton? So we solved noting that the total energy of an electron here is gamma mc square, calculated gamma to be 9.76. This is 9.76. And then we have solved for V over C. 1 minus V square over C square is gamma to minus 2. And we've obtained 0.994 C. And we have substituted gamma and V over C into this expression, taking this into C parentheses, and solved for B capital M, 1606 kilometers per second. We calculated its corresponding kinetic energy, found that it's much less than the electron and positron energies, therefore it's negligible. So roughly the incident photon has an energy 10 mega electron volts.